Hello, everyone. So before I start, I'd want us all to think about sort of the complex systems that we use, but we don't necessarily understand the details of every day. Take, for example, your standard automobile. Any car made in the last few years, even if it's on the cheap end, likely came with 50 to 100 embedded sensors, which likely communicate using a Internet of Things network, if not something synonymous to it. And these networks are very powerful and very important to the things that we produce today, but it's easy to not notice them. So I'd like to talk today on why the Internet of Things is effective and what it means for mechatronics engineers both now and moving forward. My name is Gary Mullins. I'm a junior at Texas A&M. I'm studying mechatronics engineering, which is essentially just the study of electromechanical systems and their controls. So without further ado, um, the Internet of Things sees a lot of popularity because it can provide more function at less cost compared to any older method. Ever since we've started using electronics, we've had the need to control them. And historically, this has been simple. But in the past 10, 20, 30 years, um, new methods have been produced that really improve the efficacy of communication systems. And what we're talking about today is the Internet of Things, which was the stepping stone, and it's still a lot in use. It's very important still. And it's currently, we see the Internet of Everything is getting a little bit more popularity because of the success of the Internet of Things. But so what the Internet of Things is it's what it sounds like. It is a network of things. These things are devices which connect to the Internet and can talk to a cloud computing system. As we see in a paper by Atsori, one of the key components of the Internet of Things, and one of the reasons why it's very useful, is that it can control needs produced by larger, more complex systems than we've seen in the past. So while it's not impossible to solve today's control needs with yesterday's technology, it's inefficient and more complex than it needs to be. So the Internet of Things uses wireless connections to integrate sensors with a cloud network. And because of this cloud network, it's easy to include calculations that in a traditional control system would have required some sort of logic circuit or some sort of programming to get those calculations. And at the end of the day, the Internet of Things isn't terribly new. It is ultimately just the combination of existing technologies to solve new communication needs. So the Internet of Things, it's able to communicate with and control many types of devices due to this cloud integration, um, which ultimately makes this system more effective and more productive than historical systems. So to give you all an analogy of to help you all understand, think about you have a restaurant and it's tasked with making a certain amount of dishes and a certain types of dishes in one evening. You could organize your kitchen staff in various ways to accomplish that task. One common thing is to have one head chef and then a bunch of sub chefs. These sub chefs might have tasks, but ultimately they are all going to report to your head chef. Now, this works, it'll get the job done, but that's where the whole term there's too many cooks in the kitchen comes from. When you have too many people that don't precisely understand what they're doing and how it relates to everything else, they have to report back to a higher source. So in the case of the kitchen, that would be the head chef. In the case of communications, that would be some sort of motherboard circuit or some sort of centralized computing station. Um, and this works, but a much more effective way to approach this, which the Internet of Things does, would be to have everyone in the kitchen understand what they need to understand. So they don't all need to be as experienced or expertise as the head chef, but if everyone understands what they need to do for their tasks and nothing more, things can operate a lot more efficiently. And another parallel between the Internet of Things and the cooks in the kitchen is that if each of the lower level chefs understand more about their task, they don't have to go through the head chef to communicate and get stuff done and prepared to do their tasks. Um, so likewise with the Internet of Things, we no longer have to send all of our data and our requests back to a motherboard because that can all be done in the cloud, which really facilitates one sensor talking to another. And in a paper we see by Bradley, one of the strengths of the Internet of Things is that it can prioritize data lines. So going back to the kitchen thing, if you have a dish that takes 40 minutes to make, you need to start on that before you start on the dish that takes 20 minutes to make. Same thing with the Internet of Things. It will prioritize higher level data lines. So say you're running a car, your engine temperature is probably going to be more important than your tire pressure. So in the event that you can't read both, you want a smart system that knows which to read to avoid collecting data that isn't useful. And in a paper by Clark, we see that the Internet of Things is really effective at taking on large quantities of data. And to that token, it's also very modular and adaptable. Whereas traditional systems, you set them up and they're kind of stuck like that. And yeah, so all the things on the network are able to talk directly to each other through the cloud without needing to go to a home processing center. So the Internet of Things also provides a platform that aids both producers and consumers, which we haven't historically seen something as effective. So for example, as a producer of a product, you want accurate, smart data on when it's failing, why, which one is failing. So that's all very useful. And then as a user, you want accurate readings on, likewise, why stuff is failing, what you can do as a user to prevent that. So all this data is very valuable to both the producer and the consumer. And as we see in a paper by Stankowski, the Internet of Things provides smart capabilities that were never available before. Because we can go to the cloud, we can apply programming and other computing languages to really give our systems some kick and some computing power. So the Internet of Things is really an exciting improvement in the field of mechatronics because it integrates mechanical and electrical systems with their controls in a way that's modular, adaptable, and efficient. You know, we don't have to run solid wires anymore. As long as our things come embedded with the appropriate sensors, it's very easy to hook things up and collect complex data and make sense of complex situations. So thank you all for watching.